Hello, welcome to GP Podcast. In the world of artificial intelligence, there's this silent arms race going on. It's not fought with armies, but with silicon. But what if? What if the very foundation of that race, the silicon chip itself, is about to be completely upended, and by something as simple, as fundamental, as light?
So here's what we're going to dive into today. We'll start with this photonic shockwave, this unbelievable claim. Then we'll talk about why this is even a thing, why we're hitting what's called the silicon ceiling. After that, we'll get into the cool stuff. How exactly do you compute with light? Of course, we've got to be realistic and look at the hurdles ahead. And finally, we'll ask the big question, could this redraw the entire map for AI?
Okay, let's kick things off with the announcement that really sent some shockwaves through the tech world. Researchers in China from a couple of their top universities have just unveiled this new AI chip. It's called LightGen. And the things they're saying it can do, well, they're almost hard to believe.
All right, get this. The core claim is that for certain AI tasks, we're talking about creating images, videos, that kind of thing, their light-based chip could be more than 100 times faster and more efficient than Nvidia's A100 GPU. Now, you got to understand, the A100 is the gold standard. It's one of the most powerful, most widely used AI chips on the planet. So this isn't just some small improvement. This is them walking right up and challenging the king of the hill.
The raw number they're throwing out from the prototype is just staggering. 35,700 TOPS. That's trillion operations per second. But okay, what does that actually mean?
Well, what's super interesting is the metric they're using. TOPS isn't the same as flops, which you probably know from gaming GPUs. TOPS is different. It specifically measures how fast a chip can do those very specific preset math calculations that are like the lifeblood of AI models. It tells you this thing is a specialist. It's not trying to do everything. It's designed to do one particular job and do it incredibly fast.
So to really get why a chip like this is such a big deal, we need to talk about the problem it's designed to solve. And it's a huge one. Our current way of doing AI is running smack into a physical wall, a very, very hot wall.
See, GPUs, like the ones from Nvidia, they're the engines behind this whole AI revolution, right? They're amazing at doing tons of calculations all at once, which is perfect for AI. But all that power comes with a massive hidden cost. These things are hungry.
Just think about it for a second. One single Nvidia A100 board, when it's really working, can suck down about 350 watts. That's more power than a lot of high-end gaming PCs. But of course, you're not just using one. You're building a data center. You need thousands.
And that's where the numbers just get insane. A cluster of, say, 10,000 of these, that's about 3.5 megawatts. 100,000 of them? We're talking 35 megawatts.
And here's the kicker. That doesn't even count the massive amount of energy you need just to keep them from melting. We're literally building data centers with the electrical footprint of a small city, all just to run AI. This right here is the silicon ceiling we're talking about. AI's progress is chained to this insane hunger for power.
So why? Why does this happen? It really just comes down to basic physics. Inside every one of those chips, you have billions of tiny little switches, transistors, flipping on and off constantly. Every single time they flip, electrons have to move through metal, and when they do, they create friction, basically. It's called resistive heat. Now, multiply that tiny bit of heat by billions of transistors switching thousands of times a second, and you get a massive heat problem. You have to pump all that heat out, or the chip just dies.
And that's where this whole idea of photonics comes into play. It's a totally different approach. Instead of trying to build a better, more efficient mousetrap with electrons, the question becomes, what if we just use light to do the math instead?
I mean, think about the core difference. A normal silicon chip pushes electrons through tiny copper wires. A photonic chip sends photons, actual particles of light, through tiny little pathways. And photons just don't create that same kind of wasteful heat. The computation isn't happening by flipping switches on and off, it's happening through the actual physics of light, things like interference and diffraction. The math is being done by the light itself. It's a wild concept.
Now, to be fair, computing with light isn't a brand new idea, but older designs had this one major flaw, especially for generative AI. They had to process an image piece by piece, in little chunks, and that led to these weird, disjointed results. The big breakthrough with LightGen is what they call a 3D stacked architecture. Basically, by layering all the optical parts, it can look at the entire picture all at once.
The analogy here is just perfect. Old designs were like trying to paint a giant mural, but you could only do it one little tile at a time. You'd always see the seams between the blocks. LightGen is trying to paint the entire mural in one single coherent brushstroke of light.
For creating smooth, seamless images and video, that is a massive, massive leap forward. Okay, but as exciting as all this sounds, we have to pump the brakes a little. It's one thing to build a cool prototype in a lab. It's another thing entirely to build millions of them and change the world. And LightGen faces some really, really tough hurdles. First up, manufacturing. We're talking about aligning these optical parts with nanometer precision. I mean, it has to be basically flawless. One tiny error, and the whole thing just doesn't work. Then there's the challenge of just scaling up. How do you go from one perfect chip to millions of them that are all perfect? That is a monumental task. And finally, there's the bridge problem. Our entire world is digital, so you have to convert that digital information into light, do the calculation, and then convert it back to digital. And you have to do it so fast and efficiently that you don't lose all the speed you just get.
And it's not like LightGen is the only one playing this game. There's another chip out there called Excel that takes a hybrid approach. It uses both light and electricity. But what's really key here is what they're used for. Excel is good at recognition tasks, like identifying an object in a photo. LightGen is built for generative tasks, like creating a whole new photo. This really tells you that the future probably isn't about one magic chip that does everything. It's going to be about having a whole toolbox of specialized tools for different AI jobs.
So let's imagine for a second they pull it off. It's a big if, for sure. But if they overcome these hurdles, what happens then? Well, the implications are just huge. It's not an exaggeration to say it would be revolutionary.
Think about it. A successful photonic chip changes everything about how we build data centers. It could slash those insane energy costs for AI, which would make it way more sustainable, way more accessible for everyone. And then there's the bigger picture. In a world where control over technology is a massive geopolitical issue, this could completely shift the balance of power. It could change who holds the keys to the future of AI.
But let's be super clear about something. This doesn't mean Nvidia is going out of business tomorrow. Not at all. Nvidia's real strength is its flexible, programmable GPUs and that massive software ecosystem they've built. These photonic chips, like LightGen, they're specialists, they're accelerators. They're not meant to replace the workhorse GPU. They're designed to come in and handle the most brutal, power-hungry jobs.
And that's really the ultimate question we're left with, isn't it? Is this the beginning of something totally new for computing? A technology that finally lets us smash through that silicon ceiling and redraw the entire AI map? Or is it just a fascinating lab monster, an amazing scientific achievement that just can't make it in the real world of mass production? Only time will tell, but you can bet we'll be watching. If you like the video, please subscribe, leave a like, and definitely comment on what you liked most. And of course, share the video. It really helps the channel out. Thanks for watching.